Mm. Mechanical ventilation and heat recovery, MVHR. When you're talking about passive house or retrofit or anything to do with energy efficiency within the home, uh, mechanical ventilation is key. MVHR. It's one of the five basic principles of passive house is adequate ventilation. And what is MVHR? And why do we need it? Why do we need an MVHR? Mechanical ventilation and heat recovery is exactly what it says it is. Now, the air tightness in a building is so important because this is the environment's controllable by the MVHR. So, an airtight building, the internal environment needs to be purified from harmful dust and other contaminants that may be harmful to health. This is through everyday living, and it's to get rid of all the remnants of our life, which is showering, cooking, cleaning, soft furnishings. Everything produces dust and dust mites, and all these things need to get rid of because we're in an airtight build. We don't want to live with those. So all these things need to be got rid of or thought about. The MVHR is the way we do that, and that is why we need one. We need an MVHR to take care of volatile organic compounds. This is your carpets and soft furnitures and stuff which is producing dust and chemicals. A particular matter that's from cooking and anything biological that we're doing inside the things. Carbon dioxide from respiration. If we're in an airtight box and we're breathing out, we're breathing in oxygen and we're breathing out carbons. So therefore it needs to be dealt with through respiration. That also puts damp into the atmosphere as well as we breathe. Dust mites. Dust mite feces. Dust mite feces is more harmful than dust mites because the dust mites themselves aren't particularly harmful, but the feces that they leave behind could be, especially if you're an asthmatic or have a lung condition. Mold spores, again, if you are an asthmatic or have a lung condition of any type, mold spores aren't good for you. They really do need to be dealt with. Combustion fumes. Whenever if there is a gas boiler or something like that within your property, or you use a gas cooker, that's going to produce some form of a fume. Humidity control. Too much humidity is really not good for the environment that you're going to live in, especially when you've got an airtight envelope to live in, because humidity creates damp, it creates condensation. It's something that we really want not to have to deal with. So it's dealt with by the MVHR system. Another one, sorry.
No, you piggyback on me.
That's humidity. Radon, RA, stands for radon gases. Radon gas is a natural occurring gas in the ground. Nothing we can do about it. It's there. It's always going to be there. It's in the outer atmosphere in many places around the UK and Europe. And it's a case of it can get trapped inside of an airtight build. But if you've got fresh air coming in and you've got the old air going out, it's being taken care of. It's being diluted and got rid of. So these are the reasons why we need an MVHR, mechanical ventilation and heat recovery. What is an MVHR? Well, we're going to go through a few slides and go through the processes of how it works. An MVHR stands for, as we've said, mechanical ventilation heat recovery. This is the means that we use to control the environment within our build. This machine provides filtered fresh air, at the same time removes the dust and humidity and preventing condensation. An MVHR will reuse your heat. That's what the heat recovery means. It means it recovers and reuses the heat. It'll also create a healthier healthier environment and a consistent rate. It will keep a consistency, air quality, consistent temperature, and a consistent pressure within the build. Because when you've got an airtight build, air pressure is actually can affect the way that we live in it. How does an MVHR work? It's very simple. The principles of an MVHR are actually really quite simple. It's movement of air and using nature to recover heat. Basically, it has two motors. These two motors work independently of each other. We have a motor on the intake and we have a motor on the exhaust. One brings it in, the other brings it out. The one that brings it in has a pollen filter, or a filter that is going to take out all the pollen, dust, anything that could potentially be anything that could potentially affect our breathing within the building is filtered out as that first motor or that first filter is hit by the air coming in. That leads us to the second motor. The second motor is the one that brings, that expels the air from inside. So the second motor will bring air from the inside through the heat exchanger. Itself is filtered. Because remember, when we filter air out of the building, we've got those dust and contaminants and mites and other stuff that we're sucking out of the building. So therefore, it needs to be trapped and dealt with and not go through the heat exchanger. And these two motors work independently of each other because they need to be able to control the environment at different rates as temperature changes, humidity changes, and the atmosphere changes inside and out. It needs to be compensated for, and it does this by working independently. What is a heat exchanger? A heat exchanger is exactly what it says. It exchanges heat. It uses nature. It uses what's the natural thing to happen. And that is, as things pass each other, it wants to ameliorate. It wants to become an average. So it uses air as heat comes in. We have a series of straws or a series of sort of fins or something which crosses at 90 degrees to each other. And then that way we have airflow two different directions, two different temperatures. And as it crosses, it goes through these little holes. The air doesn't touch. It just passes very close and in between each other via separated, I always refer to as straws. And that way, as the air flows and crosses, then the cooler air draws the heat out of the warmer air. And therefore exchanges the heat from one flow to another. That's your heat exchanger. It exchanges heat. Now, these could be really efficient. Now, the thing is with the heat exchanger or MVHR, mechanical ventilation and heat recovery, we get very many different sorts and they're all designed purposely for individual project. What I mean by that is if you have an industrial area, you'll need a different efficiency than you will do if you have living area for a home. So therefore, the design will be purposely designed for that particular project. We have a number of different heat exchangers with different efficiencies. You have a basic heat exchanger, which is just fins that cross each other. That's 50 to 70% efficient, depending on the flows of air. We have horizontal flat plate. These tend to be extended in length. So what they do is, if you can imagine, you've got layers of these on top of each other and they're extended in length. That means that they're 70 to 80% efficient. Now, you get the cellular ones. Now, this is where you get the individual straws or individual fins that interlock each other in 90-degree angles. This is where you get the most efficiency. And this 85 to 99% efficient I always say that they're about 90 to 92% efficient. That's the reality of it. But these are the different heat exchangers to which you can have within your mechanical ventilation heat recovery unit. So, heat exchanger does exactly what it says. It exchanges heat with the two different flows of air. Filters are very, very important to an MVHR system. We've already explained that when you get air from the outside coming into your machine, we don't want contaminants and that going into the build. We also don't want them going through the heat exchanger, potentially blocking the flow of air. So we have some really good filters. Usually you have a really good quality thick filter which takes out all pollen and all really nasty contaminants from the outside. So when the air goes through the heat exchanger and into the build, it's as clear as clean as we can get it. The other block of filters or filter is coming from the build, from the living environment. So therefore, we have to stop that from going through the heat exchanger. So filters, every design or every make and model of MVHR system will have its own filters. So don't go and think we can get 20 of one sort. We may need to get individual filters for that particular MVHR system.